Thank you, John. Thank you, Antene. And thank you, Debbie and Pinfa for giving me and iPlus the opportunity to do this presentation. And thank you to the whole audience who is attending. As Antene has introduced, we are here today to present and to talk about the, the new sustainable alternatives of this safer and greener material development when we talk about frame retardancy. Well, here we can see the index where we will be today traveling across through this presentation. At the beginning, I will talk about a little bit about Aimplus, where I work, in case you don't know us. After it, I will give a short overview of the presentation and what will guide us through the whole frame retardancy and European framework. After this, I will be talking about the context and motivation of these new green and safer solutions. Of course, we will go through the emerging strategies and materials where they have been applied and which additives are currently developing. After this, we will quickly mention which verification and testing tools are commonly used to characterize all these new developments and researches. After this, I give you a quick overview of the different projects where we are involved from Mindplus. And we will be finishing with a whole European context and global trends in these new safer and greener solutions. And I will finish with some conclusions and discussion. So let's begin with the presentation. The first thing that we face is, what is IMPLAS? Well, we are a technological research institute with more than 35 years of experience in the plastic sectors. And when we talk about plastic sector, we mean all what is based on polymers. We work with thermoplastics and thermosets, and also with all the reinforcements and additives that they use. The question is, where are we located? Where we are not in North America. We are based in Europe. More precisely, we are located in Valencia, Spain. Here, some pictures of the city. And something curious is that we are pretty aware of the fire, because some of our local festivities is based on burn some monuments that are built during a year, and they are burned to celebrate the new the new weather change. But now, focusing on our facilities, here you can see a picture of our different areas where we work with. We have the pilot plants where we develop all these new sustainable solutions and new plastics and additives. Also, we have the laboratory area where we test and verify all these new research and developments. And finally, we also work on training and events where we give courses and teach courses related with all our know-how that we acquire from the different projects that we develop. Here, some facts and figures and some numbers of Aimplus last year. We have a 24 million euros turnover, and we developed more than 290 projects, together with more than 3,500 different companies. At the end, where we work is in pretty much any area where the plastic is involved. That's the reason we have all these different sections and departments inside Aimplus. We go from the sustainable chemistry with synthesis of polymers, or decarbonization strategies, or packaging, agriculture, and of course, we have two big areas where we test our research and development, which are these two laboratories, divided in the consumer and environmental health and safety laboratory, and the characterization and testing, where I belong to. At the end, what we offer is solutions for plastics. We mainly focused our workforce on project development, both granted and directly with the customers. Also, we offer technological services, which means any sort of need of the company that can be solved with our knowledge. And finally, this training and events area where we teach all the know-how that we acquire. Well, now let's talk about the first slide of the presentation, which is an overview. When we talk about fire safety, nowadays is always related with sustainability. And we know that this is going to be a trendy topic because this market is growing and growing year by year. Here we can see this increase on the market in the upcoming years. And also we have to be pretty aware of the new trends. Which are these new trends? New additives and new flame retardants based on sustainable solutions, which are and work with non-halogenated phosphorus solutions, among others. With this clear, let's talk about the context and motivation that lead us to this presentation. Here, we can see that fire is pretty much in every sector. So we can say that the fire safety concern is a cross-sector challenge. At the end, it is present on the transport sector, the construction, or the electronic devices sector. If you look around, you can see that any furniture or piece of construction or building has to be aware of these flame retardancy properties. So on all of these sectors, we have a specific trends, which is to go towards a renewable materials or more sustainable, which mean be focused on the bio-based solutions and the recyclable solutions. And this it could be understood as a substitution on the flame retardants that we are using as additives nowadays, which are mainly inorganic and halogen. Here in Europe and worldly, they are being limited year by year by legislation. So at the end, if we combine all these ingredients, let's say what we have is to develop new sustainable flame retardants. But we have to keep in mind that the traditional ones have some advantages, of course, but some of these advantages that we have to be aware. Of course, the traditional ones are cost-effective and easy to process. So this is one of the reasons that they are widely across, and the substitution is something tricky and something that must be investigated. And they also provide good thermal stability and smoke suppression. Of course, they are also very efficient at low concentrations, and they deliver this strong flame inhibition that we look for. At the end, they have been in the market long time, so their mechanisms against fire are well known. But they are also, in some cases, have some disadvantages, like in some cases having high loadings, which will impact on the mechanical strength and impact resistance of the materials, among different other properties, and also they impact on the transparency and processability of polymers when they are used at high loads. Of course, there is also the legislation that we have always keep in mind here in Europe, which is increasingly and being more restrictive on these additives because of their toxicity and persistence on the environment. generating hazardous byproducts and impacting also on the recyclability, because when we work in the recyclability area, we can take additives that are present on old materials or materials that were left use some years ago, and they have some additives that now are not allowed. For this reason, we have a very big regulatory pressure in Europe, developing different agents and legislation restrictions like the REACH, the ROS Directive, also the Eco Design Directive, and the Green Deal and the Circular Economy Package. So if the flame retardants market is growing year by year, we have also to be aware of this safe and sustainable by design, and we have to put our efforts on the steps that we are producing in order to have these developments within these legislations and aligned with this legislation. Because if we see the flame retardants, and as I have said on previous slides, are pretty much in any product that we can think about it, like toys, furniture, even synthetic textiles. And that's why we have to be really aware of, because of their environmental and health impact that could lead the use of these flame retardants, and how they must be changed, keeping, of course, the properties and the requirements that are needed to fulfill their mission, let's say, which is flame retardancy. Finishing with this context and motivation, what we have here after all what I said is that we have key drivers of innovation, something that will push us towards the development of new flame retardants. We have the circular economy. We have to balance the properties. It is true that if they work, but they have to match all the fire mechanical and processability without changing too much our industrial processing. Also, we have to be aware and align with the policy and regulation. And something that is really important also, the cost efficiency. And all these all these keys are translated on the need for sustainable alternatives and the research on these ones, like the bio-based derived from different biomass, or if it is that could lead us to phytic acid, phosphorus, and phospholipids. Knowing all this, let's go to talk about the emerging strategies and materials. The first thing that comes into our minds is to go from halogen-based to halogen-free materials. These halogen-based flame retardants are being tracked by the European Commissions, are being pushed by restrictions. So their usage is being limited year by year. For this reason, we can go and we can face and we can investigate with phosphorus-based flame retardants and their combinations with nitrogen compounds, which have emerged as the most effective halogen-free alternatives, as we have seen. These phosphorus and nitrogen intimacy systems are based on the property of expansion and creation of a protective charge layer during the combustion. Their usage is typically around 20 to 25% load, and you have to be aware on how impact this type of flame retardants of your materials. Mostly we think about mechanical properties, but you have to think also in as final aspect and others. These type of solutions are widely compatible with thermoplastics and thermosets, and most of the formulations are based on ammonium polyphosphate and carbon source, among others, and their combinations with other synergies. This type of material, of prime material, which is phosphorus, are considered here in Europe as a critical raw material. And this is taken as a challenge because phosphate rock is in a list which push the dependency on imports. So this is an strategic vulnerability. So it's something that we have to be really aware of. Of course, it's also this type of prime material is used in other sectors like the agriculture one. So you have to, it's also pushed by the supply chains are also pushed because the demand comes from also from the agriculture side. And as we can see on the graphs, it's widely used on the fertilizer sectors. So for this reason, bio-based phosphorus alternatives is developing these bio-based solutions is essential to ensure the autonomy and the competitiveness and impact on one of the keys that we have said before, that I have said before, which is the cost effectiveness. Also, we can see the dependency of the outside markets like Morocco. At the end, this push us towards bio-based and circular phosphorus brain retardants. And the research is focusing on these new sources, which can come from biomass residues, agro-industrial products, or from recycling streams. Some examples are the phytic acid that could be obtained from grains and legumes. Also, we can think about lignin or casein derivatives as carbon sources, or recover phosphates from wastewater or ashes. All these examples are aligned with the legislations and regulations that I have mentioned before, like the EU Green Deal goals, the Circular Economy Action Plan, or the Safe and Sustainable by Design framework. But what can we do when we are developing these new additives or where we are researching? We have to verify these new formulations and these new compounds and see how they work when they are put it on plastic or composites. Where at the end, what we have here is an environmental responsibility and a sustainability framework, which looks for the security of the different sectors and applications of these additives. This pursuit of security produces the new legislations, which reflects this frame with this fire protection. And with these new legislations, some properties are targeted and must be fulfilled in order to be, again, saved. No? So all this scheme pushes the R&D, the research and development on this area. And this is translated to the evaluation of the fire behavior. And we can differentiate the fire behavior between fire resistance and fire reaction. Fire resistance is based on the material behavior when it faces a flame. And the fire reaction is more about the structural assessment or the structural resistance of a specific component made by this flame retardant material. So in order to evaluate this fire resistance, we can use a very wide testing methodologies and equipment. No, we have from the most simple approach, which is the UL94, up to the small burner or some specific ones like the CTI or the glow wire. Depending on our development, our flame retardant mechanism protection, and the sector that we are looking for, we will apply one of other. If we think about railway protection, flame retardant protection, we can think about calorimetric cone. But if we think about electronic devices, we can think about glow wire and CTI. Or if we think about construction, the small burner. And if we talk about fire reaction, it comes into our minds here in Europe, these sort of standards that we used to, and they are mainly focused on the REI parameter, which it's represented by a time, and it's the combination and the summatory of the times of the resistance of the structure, which means if the structure remains when a flame is applied, the integrity, if the whole structure it holds the fire, and the isolation, how long the materials keep away from the other side of the application flame of the flame. Times happens to it. And with all this in mind, at the end, if we are also doing these new developments to be aligned with sustainability and environmentally aware, we have to do the sustainability verification. And this means assessing the environmental performance of these flame retardant systems. And some mechanisms that we can use are the life cycle assessment, the carbon footprint, and the recyclability and end-of-life performance when we waste these materials or products. Here we can see some sort of scheme that could give us an idea of which could be the impact of an additive or a flame retardant material when used in a circular design ecosystem. We have the raw materials where we will be doing this R&D. We have the manufacturing and how will it goes to distributions and it's consumed, and then with the end of life, then or reused or recycling or remanufactured. So imagine how this additive could go back again to the production line, and this is something that we have to be aware if we are developing sustainable ones, because if they have not, they will be reintroduced on this scheme, on this production scheme. Okay, now I'm going to talk about the different cross-sector developments and case studies that we have developed here in IMPLAS. The first one that we have is the forest project. This is a European-funded project which is mainly focused on biosourced precursors with intrinsic flame retardant potential and their application on different matrix, like thermoplastics and thermosets, and sort of new thermosets, which behaves like a thermoplastic, but have like a mixed behavior. At the end, our task here was to use and to synthesize solvent-free PEX and GOPO flame retardants and introduce them into pultrusion processes for the automotive sector. But these flame retardants developed in our facilities were also applied to other ones like aerospace and the electric vehicles sector. At the end, first project is a multifunctional biocomposites is based on the development of multifunctional biocomposites for transport applications. Now we have BO4EV project, which is mainly focused on the construction sector and is based on the development of cores, mainly produced by algae, or which name is Posidonia, and the fibers for its reinforcement, which at the end what looks for is to reduce the waste of this type of algae. And here we develop it in tumescent coatings via polyelectrolyte complexes with some of our patents in this type of flame retardants, and applied on the surface of these materials. At the end, they are bio-based insulation materials which look for high performance in construction buildings. Here you can see some results on when we and the materials at the end, these insulation materials, and their performance, their total to ignition times, and their total heat release, and the usage of polyelectrolyte compounds, how this total heat release is reduced when higher was the presence of the polyelectrolytic compounds. And finally, some ongoing project, which is the Refugee project. This is a national one, and it's based on the mechanochemistry of flame retardancy. The mechanochemistry is a type of process that is based on the manufacturing of these materials through continuous processing, like an extrusion line of polymer of a thermoplastic, but with this sort of additives. Here we have developed phosphorus additives and eco-friendly coatings, and has been applied on different surfaces, but mainly wood. And this type of processes at the end are aligned and focused on these innovation procedures that we have mentioned before. And finally, finishing with this presentation, we will talk about these European and global trends. Here in Europe, as you will have seen through the presentation, it is true that the global market now is expanding rapidly with a CAGR of 8%. And nowadays, inorganic additives are the ones dominating because of their cost and availability, but they have the need of use it in higher amounts than the traditional ones. So you have to be aware on how it's impacting on the mechanical strength and appearance of your material. And also the allogenetic compounds remains efficient in their use, but they are facing a strong regulatory pressure here in Europe, and it's something that we have to be really aware of it. And the phosphorus nitrogen systems are emerging as the halogen-free solution because they are showing a high efficiency alternative. So we need to have a transition driven by this regulation and circular economy goals. And after all, we have this end of user demand across different sectors, which wants ecosystems with keep us safe and away from the toxicity or hazardous materials. So as we have mentioned, there are new strategies that we are following, like the synthesis of polyelectrolyte complex based on chitosan and phytic acid. And as you can see here, They can be obtained from crustaceans to insects, being these last ones the more promising because their production and expected materials that can be extracted from them are more regular than the other ones. And we can see here that the trend on this phytic asset market and the crustacean market are growing, and it's expected to grow a lot, as we have seen at the beginning of the presentation, during the following years. Not only on flame retardants, but other sectors. And at the end, this Europe's new regulatory direction is shifting to single chemical control to a group of regulatory approach for brominated, chlorinated, or different flame retardants. Also, the fire safety rules are being reevaluated, and they are removing the outdated standards and promoting the new ones, which are aware for the safer material alternatives. But everything, all this put it together, it's translated to a challenge because many flame retardant families are still under review. So their implementation is still slow, but they look promising sustainable solutions. But this challenge is also an opportunity because at the end, the innovation in halogen-free solutions and the recyclability systems are aligned with this safe and sustainable and eco-design regulation. So there's a lot of work to do, but it's an opportunity to change the trend and to be more greener and safer. And finally, the conclusions of the presentation. We have the global flame retardant market is expanding, but the future depends on this new sustainable chemistry, which combine fire safety, performance, and environmental responsibility. Of course, this is a cross-sector innovation and is demonstrated that the circularity and fire performance can coexist because we have seen promising solutions. We have to be aware of the ECA and ESPR frameworks because they will demand proofs on this recyclability, their carbon footprint, and the low toxicity. And the consideration of these materials as critical raw materials, because the strategy and biosourcing will shape their future and the supply chain, and ensuring this supply chain will be key in the European Union. And also the collaboration between industry, the R&D, and the policy is key for achieving these safer, circular, and high-performance flame retardant systems. Well, this is everything for today and by my side. Thank you for your time. And if you have any questions, please feel free. Thank you.